has also supervised nearly 60 MTech students. Professor Paul has built a state-of-the-art friction stir welding laboratory and metrology laboratory at IIT Kharagpur. His current research interests include friction stir welding, Industry 4.0, modeling and simulation of manufacturing processes, and rolling. Professor Paul has been awarded with the prestigious Lord Kumar Bhattacharya Chair Professor in Manufacturing for excellent contribution and fostering the industry, academia, collaboration in advanced manufacturing. Professor Paul was appointed as the Vice Chairman of IIT Joint Entrance JE 90 in 2013 and 2014. He was served as the Chairman of Hall Management Center, Chairman of Steel Technology Center, and Executive Advisor to Science and Technology Entrepreneurs Park at IIT Kharagpur. At present, he is the Associate Dean of Alumni Affairs and Professor in charge of the Center of Excellence in Advanced Manufacturing Technology at IIT Kharagpur. Thank you, sir. Within very short time, sir has agreed to given this lecture, which is which is basically our topic, that is the Industry 4.0. Thank you, sir. Can I start, sir?
Yeah.
Start.
Yeah. Thank you. Good. First of all, good morning to all of you, those who are present in this, the online seminar on sustainable and digital manufacturing towards Industry 4.0. That is the theme. I'm very much honored being invited as one of the speakers on this particular online, the seminar, the series, because of two reasons. One reason is that Dr. Kamal Pal has told, sir has agreed and he was giving thanks to me. The sir has to agree because Dr. Kamal Pal is one of my favorite doctoral scholars. He has done PhD under my supervision. When an ex-scholar requests, then obviously supervisor cannot say no. So, that is one of the reasons. And the second reason is that the theme, which is the Industry 4.0, which is very close to my heart, these days, that's why, because of these two reasons, I could not say no. And time is, is not at all a factor to me, because this is one such topic which I am delivering to large number of, the forums. This could be the 10th, the seminar on Industry 4.0, which I'm going to deliver. Just 2-3 days back on the same topic, I have delivered in one of the, the online seminar series at Parala Maharaja Engineering College in Behrampur in Orissa. It is exactly the same thematic, the area concept. The file has already been uploaded maybe in the social media, the previous one. And also you'll find exactly the same thing with a little bit of cosmetic changes. Since I have not prepared as such, so there may be some differences in the throwing of the, the delivering the content. That's all. Otherwise, the content of the slides should be more or less the same. So as I've told this, this topic is very much, the upcoming, and it has got immense potential. So let us look back into the its history. Dr. Kamal Pal has already told about me. So this is one of the pictures taken in 2018 when I was visiting UK. So some of my friends told, your gray hair is looking quite good, so let us have a picture. So that's the occasion. So, if we think of the complete, the history of manufacturing, how the manufacturing has come up and where it is going to, what are the problems we are facing. So if we unwind the time, then we'll see this evolution of the manufacturing and when the birth of industrial revolution came up and what sort of, the difficulties we are facing in implementing the Industry 4.0, whether Industry 4.0 is at all in a promising area or the promising concept, which the industry has to really think on, or if so, then what are the difficulties you are facing and how we can overcome. So that's in that way we have organized the slide. And since Dr. Kamal Pal has requested me, sir, please put some of the slides of the case studies, which I think is very, very relevant, because when a faculty member says something about some concepts and all, if some guidelines or some case studies can also be shown, so then it would be a complete thing. With that understanding, we have organized the slides. In fact, one of my doctoral scholars, Devashish Mishra, has done all this job for me. I'm just going to present that. Let us look into the manufacturing, the evolution, when the manufacturing has got started. So I think that the manufacturing, that has got started early the Stone Age area. If you think of the pictures which are shown over here, starting from the different ages of the Stone Age, like Paleolithic age, Mesolithic age, and the Neolithic age, you'll find that the shape of the stone, because the stone was, was used to, for the hunting, for cutting, and all sorts of things. So the shape of the stone, the dimensions of the stone, all these things got changed over the years. And if you see the stones got used for the cutting tool in the Paleolithic age, you'll find that there is the large nose radius. The tools are a little bit of the blunt. Then it became very sharp, and then people thought that the holding of that stone is very difficult, so they tried to put the handle onto that, so that it becomes more and more convenient to use. So use of the wooden handle was the main. Let us go to the next stage, which is the Bronze Age. Again, here you'll find that now previously the stone was used, now the metal have got started, they're using in the manufacturing sector. In that particular age, not in the manufacturing sector, in that particular age. And you'll find that instead of using pure copper, they have used the bronze. That means it's an alloy, copper mixed with the tin, with some other ingredients in it. So they try to increase the hardness of to come up with a better hardness than the copper. And again, the same thing happened. Like the shape of they concentrated on the shape of the tool, what should be the tool for the different purposes. They came up with the concept. In fact, today which we call is as the rectangle of a tool. The cutting edge, cutting surface, and the clearance surface has to come up with a sharp point. Similar thing, they tried to do by making the tool sharp and sharp. So, and then also they use the wooden handle for its convenience. Now, while using the bronze as the cutting tool, they realized that the bronze, the strength of the bronze metal is not sufficient enough to do all the job done. Okay, so that's why they thought of using the different metal, which is the iron. Now, iron is stronger than the bronze, so they replaced the bronze. So now they have started, the shifting from their the initial type of work to a different, the category of different platform. So they ventured all sorts of things. They ventured the animal power. So for some operations, you see that the evolution. Try to understand that evolution, starting from the Stone Age to the Bronze to the Iron Age. When the typical human power was used, so they ventured different types of the material, different shape, to increase the production, to come up with the the more and more convenience. So some of the jobs they found that it is very difficult to get it done, more power is required, so they tried to use the animal as the power. In some cases, they thought that it's very difficult to train the animal. Human intelligence of the power is, human intelligence is more needed. So those jobs are got done by the human being, but with some mechanisms. Now here the mechanism is now started coming into picture in the manufacturing. Then when the steam power got invented, people thought that the steam engine, the steam engine came in picture, people thought that this could be a very potential source of the energy. From there only the industrial revolution started. Then industrial revolution is basically which you call the industry 1.0. It started in the era of 1784. There the mechanisms, by the use of the steam, they came up with the different types of the mechanisms and they used it in the manufacturing. But the manufacturing sector or the production, it was very much localized because the steam cannot be transported to a larger distance. So the distributed way of the manufacturing is very, very difficult to get it done at that time. Now, when electricity 100 years later, close to 100 years later, around 90 years later, when electricity got used in the manufacturing sector, the mass production or the assembly operations, become easier. So the first assembly line in the automobile sector got used in the Ford, the company, around 1870. So now when people thought that the electricity could be one of the sources of the energy for the manufacturing, then the distributed manufacturing concept, like the same product can be manufactured at the different places, like one could be in the Orissa, another could be in the West Bengal, the same company, same product. So in that way, so the concept came up, distributed manufacturing or the mass production or the assembly operation. So that came up close to 100 years later. Then in 1969, with the invent of the robots in manufacturing and its application in the manufacturing, people thought that the processes can be automated. So because the robots are meant for the repetitive jobs and repetitive jobs with a very high accuracy, which is very difficult to get it done by the human being. Okay, so that sort of automation which you call the robots which were used in that era, which was basically the fixed automation. The robots were programmed to do a particular job. There was no intelligence, given to the robot to tackle some unforeseen situation or to tackle the real world situation. If something is programmed, robot will be doing exactly will try to do that. If something happens, some changes in the environment happens, it was not possible to get it done by the robots. But any job which was programmed, so that could be, or the robot was programmed, that could be, that got done very effectively. That was in the era of 1969, again 100 years later. Now today means close to 2014, when we started, using much of the what is that, the network internet thing, the computer price, that came down, network, the facility also got enhanced. So people thought that, the network or the internet or the cyber systems can be very effectively used to harness a lot of information out of the manufacturing process. So there is basically the start of the era which is called the Industry 4.0. It started in Germany in 2014, and with a lot of the hopes, and then people or the manufacturing sector across the globe started thinking that this could be very, very potential area, and each of us should think very seriously how that could be implemented as per our own manufacturing scenario. It's very difficult to replicate the things which is getting done elsewhere. It has to be customized, thinking of your own infrastructure, thinking of the own the problems of that land. So the integration of the physical and the digital world, this coordination is very, very important in today's era, which is the cyber physical system. So that is the total evolution of the industry started from 1784, and it is still going on 2014 onwards. The Industry 4.0 era is going on. this is a very, I mean, this particular slide I really like, that's why I present everywhere. You see that, you know, today we are very much accustomed with these gadgets called the iPhone, iPad, Kindle, 4G, Uber, Ola, Airbnb, Android, Instagram, and WhatsApp. You know, I don't need to explain what are these things. All of us, we know that, you know, it's important. Every now and then we are clicking photographs and sending it to our near and dear ones. Every now and then. Okay, we are getting so much connected socially these days, it's unthinkable. So having experienced that one, and if you look into the red colored note which is given at the top, this didn't exist 13 years back. That means 13 years back or the 14 years back, the life was different. Now with these gadgets coming up, we are so glued to this, then our lives are also getting, you know, the change. This is very, very, you know, interesting slide. You just very carefully observe that. You know, the telephone got invented in 1874. 3 years later, people started using it. So it took 75 years to reach to 100 million customers. 75 years. And the era was 1870. Now, in 1980, so close to, let's say, the 100 years later, the web came up in picture, you know, in our life, and it took only 7 years to reach to 100 million customers. Facebook, 2003, that means again close to 23, 25 years later, Facebook came up in our life, and it took only 4 years to reach to 100 million customers. You know, that is the initial phase. Now the growth rate is much higher. I'm telling only the best, you know, the target is that 100 million customers. How fast it took to reach to that level. Instagram came in 2010, 7 years later. It took only 2 years. So the period got reduced to half. And Pokemon Go, it came in 2016, 6 years later, it took only 1 month. 1 month to reach to the 100 million customers. That means with this starting from 1877 to today to 2016 onwards, so this period, if you see over these generations, you know, the gadgets are coming into our life very, very, you know, crucially and effectively, and we are trying to use that one. So these generation people are smarter in using the gadgets, smarter in deriving the analytics or doing the more and more analysis out of the process itself. If some problem come up in my computer, instead of calling the experts, I just request my daughter, you just solve this, this thing or that thing. She does immediately, which I am unable to do it, because I am 30 years senior to her. So the age, with that generation, with that different types of the gadgets coming up, our new generations are becoming more and more smart. Not only the human being, these concepts are also getting used grossly in the manufacturing sector. So the verdict is that समय के साथ चलो, समय के साथ चलना पड़ेगा. So that is, we should not think that I am becoming aged, or this is not for me, this is for the next generation, or it's something like that. Should not be, this sort of biasness should not be there in our mind. I'm just becoming the emotional in delivering this lecture, because the topic, as I mentioned, is very close to my heart. I'm just giving a very very good example, which I consider is the very good example. My father is 85 years old. Now, just 1 year back, he has been introduced to, not 1 year, 6 months back maybe. So he has been introduced to the WhatsApp. Now he has, every now and then, he is connected to me, sending some messages or forwarding something or like this. Think of the age, 85 years. And he has opened a Facebook account also. If I post something and then he is writing, okay, beta, go ahead. So that sort of inspirations I'm getting from a person from which is very close to me, my father, and whose age is 85 years. And he has also adopted, these sort of digital, the media or the gadgets. So, and he is enjoying. When I asked him that, how do you feel? He said that at least at this age, when nobody comes to me and talk to me because of my age, because of my different thought process, and then juniors are having different thought process. Generally, there is if you observe, the juniors do not go close to the aged person because of the different thought process, interactions, and all these things. At least he is finding his own way to get himself engaged. So everything has got its, the benefit, and we have to very, very positive in mind to take up the positive thing out or advantageous thing out of these gadgets to get it implemented in our daily lives and also in the manufacturing sector. So the evolution which I mentioned started from the Stone Age, Bronze Age to Iron Age to Machine Age, and then the Industry 1.0, 2.0, 3.0, and 4.0. All these cases you will find there is a effort to reduce the cost. There is an effort to increase the productivity, to increase the precision, and also to ensure the quality over the batches. This is the thrust. This is the mandate that the people, over the usage, over the generation, over the usage of the new and newer technologies and the digital technologies nowadays. This is the object. These are the objectives which have to be fulfilled. Now, if you think of this Industry 4.0, since it is network based, so you can monitor and the process, you can acquire large number of data through engaging different sensors, sensors at different locations of the manufacturing process, different sensors to be fixed on the different components of the systems. So that means you are getting large number of the data, and if you can apply the digital tools like AI, ML on these things, then you can very easily predict the detection, predict the failure. Now, out of this data, you can also develop a model which can give you the guidelines like how is it performing, whether it will perform in the same way in the next 4 hours or not, whether something is coming up, so that is some anomaly, whether is getting is going to come up in the system or the process, that could be very easily the predicted. In that way, you can reduce the downtime. So real-time decision and control can be very easily done. At the same time, when you are collecting the data from the different locations of the process and different parts of the machine, you can get the information that how much effectively a particular machine is getting used, whether some changes could be made in the system or not. These two the sentences which I have told is very, very crucial in coming up with a smart product, and that is very much crucial in these days to overcome the present manufacturing scenario by using the digital tools. So by using the implementing this Industry 4.0, you can monitor a process, you can predict a failure, you can optimize the process, you can have proper decision and control, and you can also think of the smarter products or the flexible products. Smarter products or the flexible products means that if some demand of the consumer the changes, it's not a fixed demand. So how effectively the product can deliver that? Okay, and what would be your manufacturing system or the scenario to produce that smart product by using these digital tools? So the components of the manufacturing Industry 4.0, Industry 4.0 is not a single concept. It is an umbrella. Under this umbrella, different concepts are there, different modules are there. These are the modules like the cloud computing, big data, simulation, Internet of Things, system integration, cyber security, additive manufacturing, autonomous robot, augmented and then the extended reality or the mixed reality. Now, each and every module has got immense potential. Now think of this cloud computing, the system. Cloud server is basically computers or the cloud server is basically a remote server. So that means if you are collecting the data from a machine, from a particular machine, and if you send it to the cloud server, then the data can be remotely accessed. Now think of a manufacturing shop floor where large number of machines are there. If each and every machine is connected to the cloud, then each of those machines can very effectively send the individual data to the cloud. And remotely placed server can access or can have all this data, and then someone can accessing that remotely placed server will have all sorts of information readily available. Now with those information, the person can get to know that what is the thing happening in machine number 1, what is the thing happening in machine number 2, which is located in let's say the place X. Machine number 1 is located in the place Y. So but the person is sitting in a place called A. So a person sitting in a place A is going to get is getting the information of the particular machine which is located at X place, and also the information about the machine which is located at the Y place. In that way, the large number of the data or information can be acquired, and those informations can be very easily or effectively analyzed by using the tools like the artificial intelligence, machine learning, deep learning, and you can extract very useful information as per your need. So that means the big data, large number of information is that big data. Now big data could be in the different formats, the different modes. So those data need to be analyzed, and based on the data you can do a lot of simulation as well. As I mentioned, you can develop a digital simulation is nothing but the digital world, digital model, and you can get a lot of information out of that. Internet of Things is the networking of the things which are the based on or connected to the cyber systems or the internet the system. That means if machine 1 is one thing, that is connected through internet. Machine number 2 is also like that, and there could be some other things, not a machine, but the other thing can also be connected to the net or the cloud. In that way, you'll also get to know the information. Now, all these things needs to be integrated to a particular system so that particular platform you'll get to know what is happening in all these places. But there is a threat, like whether you are getting the actual information or not, whether that information is very much crucial or confidential, that should not get leaked. So the security system has to be kept in place, for while harnessing the data. Now another the thing which is coming up in the manufacturing sector, which is called the additive manufacturing or the 3D printing. It is a completely different manufacturing paradigm to come up with the intricate, the shaped jobs. So if something is coming up in your mind, if some design is getting done, very quickly you can get it fabricated by using this, the layer by layer printing of the materials. It could be polymer, it could be the metals, it could be the hybrid things. And today, even it has gone to the level of printing concrete. I'll also show you some of the examples of that. Then the robots. Now robots, which were used previously, those, as I mentioned, they were the fixed program robots and all. Now the people are thinking of whether the artificial intelligence or AI, ML, DL, these concepts can be, or the sensors can be integrated or impregnated into the concept or the mechanisms of the robots. Then robot can be autonomous. That means it could be very much flexible or in tackling the real world scenario. Now, beautiful concept is the augmented reality or the virtual reality. This also I'll tell one of the slides are there. So I'll show you the example, what it is and what is its importance and all. So those are the tools through which you can enter into this digital world in augmenting your manufacturing scenario. And those tools are collectively called as the Industry 4.0. So, you know, these examples I have also told in other places, like the concept, you know, if you think of the sensor, it is not a new concept, because this use of the sensor was there with us, you know, long back. Doctors are using the stethoscope. Stethoscope is nothing but a sensor. So it senses that one, but there was no AI or ML or DL at that time. It is the doctor's brain which is the AI, ML, and then DL. Now getting the sound from the, you know, or perceived by the sensed by the stethoscope of for a heart, and the doctor used to put their brain to find out what is the anomaly, whether it's a healthy heart or something is happening, you know, what sort of you know, the things happening, and then how it can be you know, corrected for what should be the medication and all these things. Now, so AIML was used by, you know, by the human doctor. Now, if you'd like to engage using the expertise or you know, if you can build up an expert system using the brain of the doctor and applying the AI, ML, and all these things, then it could be a completely automated, you know, the sensor-based system for monitoring the quality of the heart. So the manufacturing process, when we talk about these Industry 4.0 applications in manufacturing, it is basically mean the manufacturing process automation. So that means you have to instrument the process with the sensors so that you can collect the data in the real time. Collection of the data in the real time is very crucial, because you can monitor the process, monitor the process, you know, remotely. So the data analytics or the signal processing has to be done. Then only you can do the monitoring. And then not only the monitoring will serve you the purpose. So you have to control. So that means there should be a feedback path or the feedback loop, so that if something is happening, the process can be controlled. The parameters can be controlled so that the process quality or the product quality is ensured. Now, all these things need to be, as I mentioned, the effort should be to do it, you know, remotely, so that by using the cloud, that means you know, the person's concern can be sitting far away from the system, you know, and we get all sorts of information. And having this data, people can create the digital twins, which is the digital twin means the replica, and digital twin means the digital replica of a physical system. When we call is the twins, we generally refer to the human being, and both are the physical system. Now, when we talk about the digital twin pertaining to the machine, that means the physical system is that machine, and the twin is in the digital form of that machine. It is nothing but when you are capturing the data by using different sensors from the machine, and you are portraying the performance of the machine, by collectively acquiring the information from the different components. Like one could be the heart, which is like the, you know, the motor of the machine. What could be the feed movement, that is the table movement, and then tool movement, spindle movement, the hydraulic oil quality, temperature, whether there is any leakage, vibration. All these are, you know, the data can be harnessed from the different locations of the machine, and then you can analyze. That is called the digital twin. Now, digital twins can be of two types. One is the data driven, that means by using the sensors data, and it could be also the physics-based model, because it is very difficult to get information from all the points of the machine. Somewhere you have to depend on the sensors data. Somewhere you have to develop a simulation model, physics-based model, by using the sensors data, so that you can get to know about the thing happening in that particular component. So the approach, when you talk about the digital twin, our approach should always be a hybrid thing. That means the integration of both the data and also the physics-based model. We are working on these aspects, the thing. Now, if you think with an open mind about this industry 4.0, if you sit, very peacefully, close your eyes and let your minds to dream about what should be the manufacturing process, forgetting about whether you are Surjya Pal, you are Kamal Pal, or you are XYZ, Devashish Mishra, or somebody else, Santosh Sahu, or whoever it is. Just close your eyes and think of and let your mind to dream, and you will see that our mind, wants us to get all these things, all this information. That means if I could get to know what is happening inside the machine, how can I ensure the performance of the machine? How can I tackle these unforeseen situations? How can I get this information of the machine, because the sensor is not very difficult to integrate? All these questions will be coming up in your mind automatically. So in my understanding, Industry 4.0 is the implementation of the common sense. So the 3D printing, the manufacturing is, as I mentioned, that it is very, very potential area, very upcoming area. It will change the manufacturing scenario grossly. Why? Now, as I mentioned, that if something is coming up in our mind, very easily we can print it. Now, these days, the people who are young minds, who are thinking of opening up the startups, they are having some design, but they are facing difficulty how to machine this. Conventional manufacturing is for the conventional, but if you adopt the conventional manufacturing, you have to grossly depend or apply the concepts of the design for manufacturing. That means if something you have designed, it may happen that you are not able to manufacture it if you use the conventional route. Because some cases you will find it's a complete roadblock. There is no avenue to cross that block and then go ahead. But if you adopt because of the restrictions of the limitations of the conventional manufacturing process. But if you apply the printing method, then you can have different, you can overcome those obstacles. Very easily, you can print both the metal and the polymer together. Very easily, you can, not very easily, but the concept is very promising, and people are working on this, which is the sensor printing. Think of that if you are having a member, let's say that if you are having a solid iron member, you would like to find out how much is the deflection. So you have to put the strain gauges over there, and then you have to find out, let's say when you apply the load, you will get to know that how much will be the changes in the voltages corresponding to resistance and corresponding the length of the changes of the strain gauges, and find out you can correlate it to the deflection or the bending. Now, that is not possible to get it done internally. That means if the deflection is to be found out, then you have to put paste the strain gauge onto the surface of the component or the member. But when you are printing that job, layer by layer printing that job, you can also print. If we have the proper algorithm to do that, then you can print the sensor material while printing the job itself. Then sensors should be impregnated inside the job, and that along with this, the electronic circuitry, and then you can have the complete inbuilt sensor, the component. This is not a dream. The people are working on that, got some success, and very soon you'll find that the components are coming up, completely printed, and not only completely printed, it is printed with the sensors printed on it, inside it. And as I mentioned that it is also, it has crossed initially, it was used in the polymer sector, and then the metal, and then and different types of the metal. And starting from the titanium to the iron-based metals and all. And now people have ventured or they explode into the construction area. You see, these are all, this is the way the manufacturing evolution, that came up. Start Stone Age, Bronze Age, Iron Age, and the Stone Age, Bronze Age, and Iron Age. It was mainly limited with the human power and also the animal power with a little bit of mechanism. When the machine age came up, it is the mechanism, they got into the, with the use of the mechanisms, the manufacturing got done. Then the start of the modern age and industry 1.0, 2.0, 3.0, and 4.0. Over these, in fact, starting from the Stone Age, as I mentioned that the people, given a thrust to reduce the cost, increase the productivity, ensure the quality, and also they come up with a better and better precision. Now, with this application of the digital tool, people started his journey in manufacturing sector. 2014 onwards, since it was a concept, because when a concept, that comes up, lots of efforts are taken to convince the human being, and so that people get to know its importance. And this convincing human being is a difficult task. So that's why the lots of seminars, forums got done, and people are coming up with some sort of case study so that it can be demonstrated. Not everything is given on through the the seminars. Then people will think it is still in the research stage. It has not ventured into the the experimental domain. While doing that, as I mentioned, this is the 10th seminar I am presenting. Almost, I mean, it could be 8, 9, or 10. I just vaguely I can recollect the number. So every forum, last 1 year, lots of discussions were happening, through different agencies like the CII, the FICI, NASCOM, BCCI, MCCI, FOSMI, EPC, and also in the educational institutes like yours. People, on conducting seminar to get to know more about the industry 4.0. and to bring the industries on board, because this is a journey where both the industries and the academic or the research institutes are to be present. But while it was a very good start and people were almost getting convinced, and 2019 1st December, the outbreak of Corona, that happened. And since then, everything, initially it was decreasing. Now it is almost completely stalled, because the WHO declared it as the pandemic all over the globe, and from March 25, we were almost completely in the lockdown. Academic sector is completely locked down. Our scholars are unable to visit to the lab since March 25th, 2020. And now they have gone to their respective native place, and they are unable to do any experimentation. Our institute is also locked down for the last 7 days. It is very much essential to be physically separated at this moment, in my understanding, because the chain has to be broken, so that the spread rate comes down and comes down a lot. Now the COVID is posing threats to all of us, and how much threats it is the posing. When we talk about what is how much the world is getting affected. So while discussing on that, we first think of ourselves only, like how am I the getting affected. If I think when I talk about the how am I basically mean mean Surjya Pal. So in that case, I am missing my activities. What are the activities? I am missing my students, as I mentioned, that the scholars, I am unable to see them. Though I am seeing them over the VC, but that is not at all satisfying. because I cannot interact with them on the technical matters. I cannot socialize with them. I am, the missing the evening snacks in the lab when I wish to have a very, free chit chat. I am missing my biking, so I used to love like a lot. So that is also, I'm missing. So these are all personal, the things which I am missing a lot because of this COVID. So you may also be missing something related to this, or maybe slightly different, but all of us are, getting affected. Think of the manufacturing sector. Manufacturing sector, it is getting affected, through different, the types of the modes. One is that the short-term effect, another is the long-term effect. Now, short-term effect, what is the thing? Now, we got so much panic initially when the COVID came up. We purchased, the lot of things which were not needing at that moment. So there was a lot of purchase, happened all over the country in the personal care or the pharmaceutical products. Now, when sudden rise took place, that means the demand increased very grossly on personal care or the pharmaceutical, the products. The industries were not equipped to supply. First of all, the infrastructure was not there. Second thing is that the people, the workforce, started getting depleted. That means they thought that it is not safe to stay at the workplace. It is better to go back to my own native place. It doesn't matter whether I'm, the financially getting affected or not. Life is the most crucial thing. So they came back. As a result, industry didn't have the workforce to meet the demand, so they could not supply. So these are the products where there is a huge demand. There are other products where there is a dramatic drop in the demand. If you think of the purchase of other things like the purchase of the automobiles, the purchase of the bikes, cars, and other things, even the clothes, garments. Since we are not going out, we are confined ourselves. We are not needing much of many of the sophisticated and the garments, and on top of that, switching to our the nature of work, and on top of that, it is the numbers required are also very less. So that means the garment industry, automobile industry, in those places there is a dramatic drop. So the long-term effect is that, as I mentioned, the people, that is the workforce, because you try to appreciate that our industries are mostly the manpower driven. Very few industries are there which are fully automated. Not all the products can be produced fully through fully automatic system. So one thing is that less of automation, and thing is that some products are there where full automation is very difficult to get it implemented. So those sectors got grossly affected, and our country is largely hit because our country, manufacturing is purely, grossly the manpower driven. So in that case, the people who came back to their native place, they are having the fear to go to their the workplace again, because they may face the hostile situation in the city of workplace. Landlord may not be willing to give tenancy to this workforce. Think of that. This is happening. This I told sometime in April in one of the conferences in the webinar in the CII. Very recently, I came to know that these are the things happening. That even the landlord of a, let's say the Maharashtra or landlord of a West Bengal are not so much willing to give to the accommodation to the tenants who are coming from different places. It is not only, it is not a state specific, it is happening to even to your state also, to my state also, everywhere in our country. And on top of that, there is a travel restriction. Because they cannot, even somebody who are staying close by, they do not need the accommodation. maybe 30 kilometers or 40 kilometers away from their workplace or places. They used to travel, commute on a regular basis. Now they are unable to do it because there is no public conveyance. Please mute the microphone. You know, some of you are. Please mute the microphone. You know, if any question is there, we'll ask. You know, you can ask at the end. And at the same time, the social distancing, I would say that it's the physical distancing. Social distancing is not a good term. In my understanding, I may be wrong. So physical distancing need to be enforced for quite long time in the shop floor. That means the way the manufacturing was getting done, the rate of production was getting done, that cannot be, that is not possible, even though you are having the manpower locally. Even though you do not need any accommodation, even though you do not need any public conveyance, you do not need to depend on the public conveyance, you do have all sorts of, you know, all manpower that you need, but you cannot get the same rate of production because you have to maintain the physical distancing while getting the operations done. So these are the long-term effects. Even, I mean, one has to appreciate this and think that how effectively the digital tools can be implemented to overcome these situations to go ahead with their the sale of the products. So as I mentioned, the production may not be continuing full-fledged because of these things. So these are the threats, long-term threats, short-term threats to the manufacturer. So these days, at this moment, the manufacturers need to depend on something, or they need to, you know, grossly think, deeply think on something, and this thought process has to be continued even for the days to come. First thing is that if we segregate the thought process into three different, the concepts like the survival, recovery, and the business. This idea, I may disclose that this idea is not mine. You know, while preparing any slide, while delivering any slide, while giving a lecture on any topic, I need to study a lot. So I studied this one while giving a lecture at the CII conference. Then I found that people are, you know, the mindset, people have commented that the mindset of the manufacturers or the industries has to have these three, these three modules in their mind, like how quickly we can survive. And so the strategy is at this moment is that to survive. Somehow we have to survive, forget about the business at this moment. We have to quickly survive to overcome this the scenario. And when we are in the process of the recovery, now the recovery process has got started because the COVID is there with us in our lives for quite some time. And with this environment, we have started, the working. So people are thinking like, how quickly we can bring back the normalcy. People have started working, so the recovery phase is going on. And the third thing is that the business, like, even though I have recovered, I need to do something, I need to think something so that if similar situation comes up in future, I can, I can survive. At the same time, so that means the production, the product which I am producing has to be very, very smart, very, very agile, very, very resilient. So the fundamental questions should come up, or maybe it is coming up in the minds of the manufacturer, like where the weaknesses, why did we fail? Where did they, why did I take the costly decision? And why at all I have taken the costly decision? And what could have been helped me? If these fundamental questions are asked several times within ourselves, even in a manufacturer, as a manufacturer, if you think yourself, then you'll get the solutions. You'll get the solutions to ramp up your manufacturing so that your manufacturing, while producing a particular job, can also produce something else simultaneously and for the greater cause of the society. So, and that is possible if you have the complete visibility of the manufacturing, the job that you are getting done. And that complete visibility of your shop floor, complete visibility means that not only the machine, even the human being, how long a human being is getting engaged, for what purpose, what is the job a person is doing. Or when you start analyzing that one, you get to know that where is the lacuna. So I'd like to, so you have to be very, very positive in mind. Everybody has to be very, very positive in mind. And I'd like to quote the very famous, the sayings of the Thomas Alva Edison. He told that, whenever he failed, he used to think that I have not failed. I have just found 10,000 ways that won't work. In our research as a researcher, when we do something, try to do something, and then fails, then that means we are not failure. We are getting an answer that if we take this path, that will not give me the success. That means that path has to be avoided. And that's why, there is a common tendency of the researchers to showcase only the good results, which is a very bad culture. The research publication, when you come up with any abnormal result, you should do the repeatedly, and when you all the time getting that abnormal result, you must report that result and try to find out that why it is happening. Tell that audience means the other researchers across the globe, that I have used these, the process parameters, omega, B, delta, these, that, blah, 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 blah. And because of that, I have got such a low force or low power or something like that. So that means others should not use it. So that is also a solution you are giving it to the entire research community and something like that. So that was, for the startup, I'd like to say that if you fail, take it in a positive spirit, that you have found out a way that is not going to serve, or that should not be taken forward. Later, you should try the other avenue or follow the other path so that you can go ahead. So, but the concern is the MSME, because the MSME is the micro, small, medium enterprise prices. They are the backbone of our Indian industry. The 80% of the manufacturing GDP is from these MSMEs and all. And as I've told that most of the cases, our job is fully the manual, the manpower driven. So that's why large number of people are getting engaged in the MSME sector, which is basically in the supply chain of the big industries. Big industries grossly depend on the MSME sectors. Okay, so that means, and now the COVID is posing a serious, the threat to these MSMEs, because they are having very less migrant, the workforce, skilled workforce. That's a very, if the people getting affected, so that means the skilled workforce number is also getting reduced. They are not, used to the new technology, especially the digital technologies. They are still depending on the old concepts or the old machines. So they need to be adapted, quickly about the digital technologies. So as academician or the researchers, our efforts should to give a proper guidance to the MSME sectors, to make them educated so that they get to know what are the digital tools can be applicable. You see that if I give a very costly solution, solutions could be many, but when it tell that solution means that it has to be, very quickly adapted. That then only it is called the solution. If I tell something and then which is very difficult to implement because of its very hard costly infrastructure, then nobody is going to use that. Nobody is going to use it because the market is very, very competitive. So that's why the efforts to reduce the cost, but it has to have a very high quality. So these two factors are, the very contradictory, opposite, the objectives, but it has to be fulfilled. That should be the balance between these two. Otherwise, even though you come up with a solution, that will not be sold in the market, because the market dynamics is different. You think, that every other day when you want to purchase something, we immediately type it in the Amazon or the Flipkart or the somewhere else, and then just try to see that, which product but particularly suits me and will suit me, and what is the cost, where it is getting, where I'm getting at a cheaper cost. So there is a huge roadblock, for the MSMEs to use the digital tools and to combat the COVID-19 scenario. So we have to, because they are not depending on the digital tools, they do not have the idea or the concept, and they are having largely the traditional machines or the legacy machines. And of course, they do not have the proper effective marketing strategies. So our efforts should to give them the complete education and guidance. So from COVID-19, the COVID-19 is also, not everything is bad. Something is there which we have not thought of earlier. Now it is becoming, as a part of our life. So that means we have entered into a new normal scenario. We were normal previously. Now we are not abnormal. We are entering into a new normal scenario. That means we are getting accustomed ourselves to, the work effectively, from home while sitting at home. You have to follow something, some guidelines, something, then only the success will come. One thing is that you have to follow ethics. And professional ethics is one thing, is that you have to true to your job. Even though you are sitting at home, you have to utilize that time effectively for the job that you used to do previously while visiting your workplace. Sitting at home and doing nothing and telling something that I am working from home will not serve, will not take our country to a larger stage and all. So there are now, having this situation, people are finding out that there are some jobs where the physical presence is not needed always. So that means that some jobs could be done while sitting at home. You see that today I am giving a lecture, sitting at my, the bungalow at IIT, the campus, and I've visited your university, I think twice. Now, if I would need to visit the Burla for the third time to present a seminar, definitely I would have felt good, because I could have met Kamal and others there. But at the same time, I'm saving a huge amount of time. So that means the carbon footprint, I'm not consuming, I'm not using the public transport as well. So I'm also helping the world to reduce the carbon footprint. So the seminars and then meetings can be effectively done by using even the lecture classes. Those who are studying abroad, used to study abroad, and they came to their the native place and could not visit to the universities abroad because of this COVID. Now they are sitting at home and doing the online classes. Similar thing is also in our country. We have started giving lectures completely in online. Maybe in your place you have also started doing that. So we are facing a little bit difficulty, but the situation is improving. So that means that there are some avenues. Not all the things are we should not take it in a negative spirit, and we are maintaining the physical distance while keeping our business running. Our business is giving lectures and conducting seminars at this moment, but we are facing difficulty, of course, in the experimental research and all. So we need to find out that how that could also be done. Maintaining the physical distance or visiting the labs in a structured the manner. So for this we have to depend on on the digital tools for the growth of the industry. So as I mentioned that, and world is experiencing this pandemic, so all of us at this moment, passing through the very critical time, our job is to be, we should be, the very much the staying at home and stay safe. That's the first thing, which is the survival. While being survived, we think to, the thing for the recovery, and then we also need to plan how we can get into our business, which is our own respective work nature. You believe on this, the comment like nothing lasts forever. So so the coronavirus as well. We need to work together. We need to break this chain so that we can defeat corona, and corona becomes, just like other virus, like the other influenza and other things. So how Industry 4.0 can help in the coming days while combating this, the COVID-19? It will help in automation, because the more and more companies will survive. We implement the AGVs, automated guided vehicles, robots, and then drones. And we can use this digital twin, as I mentioned, the digital replica of the physical system. We can use the concept of the augmented reality or the virtual reality, so that we can predict something going to happen. How can you optimize those processes? All these things, recovery, and then your to make you more agile and more resilient about your new endeavor, that can be very easily done by using this. And as I mentioned, that these are the tools, AI, ML, and DL. And also, when you come up with a new concept, new design, you can adopt this additive manufacturing route to very quickly you can produce the prototype and get to see that how does it physically look like. That is also very much important. What are the different differences, which were not possible to visualize by using until and unless the product is getting done, and then manufacturing of the product was not always possible because of the limitation of the conventional manufacturing routes. So visualize this, the utility of this tool. All of us are matured, and we are very much accustomed, very much familiar with this tool. Just we need to think that the AGVs has got the very high potential in transporting materials. Now, if in a shop floor, if the material is to be transported from one place to the other place, you do not need the manpower. If you use the manpower, then the question of the physical distancing come up. And then at the same time, the use of the manpower effectively in different shifts. But you can get it done repeatedly and accurately if you can engage the AGVs. Similarly, for the drones are very much useful for the inspection, surveillance purpose, delivering products. This is not a concept. This is being used even in our country during the lockdown scenario, initial phases of maybe the lockdown 1.0 or the lockdown 2.0. Telangana government used this, the drones to ensure that effective implementation of the lockdown in different parts of the country is getting done. So that means we are not lagging behind. We are also making use of these digital tools or these modern concepts, and for the different the applications. There it is for the surveillance purpose. The robots. Now, as I mentioned, that the robots in 1969 onwards, that the Industry 3.0 era, that was the fixed automation. That means the robot was programmed to follow a definite path. If something comes up in that path, robot could not tackle that one. It is to hit that thing. Now the flexible automation is coming into picture, and then the AI, ML, and then the image, the cameras, the signals, sensors, all these things have come up very much in manufacturing the process. If those the tools can be, signal processing can be done, image processing can be done, AI, ML can be used, all these, the digital twins can be developed, so that the robot can take a decision and control or maneuver its movement. And these days the robots are getting used grossly, starting from not only in the manufacturing sector, it's also in the medical sector, and it got used grossly in China in different hospitals for delivering medicines, food, disinfecting the rooms, and in sometimes to provide some level of companionship for the people in quarantine. Think of the people who are in the quarantine in the hospital. They do not have any visit from any of their close, near and dear, the relatives. So they are facing a lot of. They are feeling having a lonely the feeling. We should give we should have given proper company to them so that they can overcome the situation very quickly. But that is not possible. Physical visit is not allowed. So that means they are the chatbots or the concept, the conversational AI is there, which I'll also mention later on. Now, another thing is that as I mentioned, the teleservices or the remote assistance, which is the cloud computing. So as I've already told, because you do not have the proper the workforce in place at this moment, but you need to get the manufacturing operations seamlessly done. So you should have a proper, the central, the server, central database, which is the cloud, and all machines or the entities of a shop floor can be connected to the cloud to get, to gather as much information as possible, so that if you can effectively get the information about the shop floor and make your shop floor more agile. So this use of AI ML, use of AI ML and DL, those things are very much coming into picture to create a digital twin for derive the predictive maintenance. I've already told I don't want to spend much time on the additive manufacturing. So just to tell that the importance of the manufacturing is the bringing design and innovation to the forefront very quickly. That's the very much effective. And I promised to show you some slides on the additive manufacturing in the construction sector. You just very carefully read the content of the slide. The 2015-16, the world's first 3D printed building came up in Dubai. Okay, so and it was the building area was 2,600 square feet. It took 17 days to print and 2 days to assemble. The building, the component was printed, concrete component was printed in Shanghai, shipped to Dubai, and assembled there in Dubai. Think of that potential of these things. Something is getting printed, in a different country, being brought to the site and assembled in the site. And by this way, and very quickly, in 17 plus 2, that means 19 days time, a building, office place is getting constructed, which is up to 2,600 square feet area. Labor reduced is 50 to 80%. Construction weight reduced 30 to 60%. And also, as I mentioned, that it started in 2015-16. 2015, the 3D printed villa in China, total area is 11,840 square feet, printed on site. 2016, another building, 2-story building in China, total area is 4,305. Think of the potential of these, the thing. These pictures are taken from the internet. The sources are also mentioned there. Now, AR and VR, virtual reality and then augmented reality. This thing has got immense potential even for the academic sector, and I'll tell you how. The virtual reality, if you tell this term, twice or thrice, virtual reality, it means that we are getting the real world feel in the virtual area. That means we are completely immersing ourselves in the virtual area to get the feel of that real world. So that means something is, if as you are entering a shop floor, you in normal shop floor, if you physically visit there, then you will get to see all things are happening in front of your eyes. Now you cannot go there. You cannot do the experiment. But if the experiments could have been done virtually in front of you, interact while having the interact. If I press this button, what will happen? So you are virtually pressing a button and see the performance of the machine virtually, which it used to happen in real world. That is called the virtual reality, and that is very much the coming in our lives. Very some of the industries have done their training programs, develop the virtual reality model, and now in the academic institute we must think on that. We have to be progressive in mind. We have to invest we create infrastructure in this particular area to take your manufacturing into a different domain. So the automotive sector, automotive sector design is one of the crucial components. How would the vehicle look like? If a design like this, it is not only a static design. You need to interact with that one. You need to get inside the car and then close that door and feel like how this is happening. So if you are having a complete virtual model, and as if you are entering into this virtual model and seeing that how do you feel like, then only it will be if the motion is giving to the car, and then how are you going to feel it? So instead of creating the complete physical model of a car, running it and then running it on a different the roads and feel that actual the feeling physically, you can get it done by using this through virtual reality. Augmented reality is one step ahead. That means you have got some physical thing with you. You would like to design something virtually, and which is needed for that component, or you have to check the performance of that component, having that physical systems in place. That means you have got let's say, giving an example, you have got a motor. You would like to design an impeller, so you are designing an impeller, virtually fit it into that, the physical motor, and see that how this combined system runs. That is called the augmented reality. As I mentioned that we need to give the companion, the efforts in the China hospitals, people, the robots are there which are giving companion to some extent to the COVID patients because they are feeling lonely. So the concept is nothing but the chatbots. Chatbots is nothing but the conversational AI. That means if you are asking something, then by using the AI, by using the answers, expert systems ready, or the information inbuilt in it, it is trying to extract that the information out of the existing experts, expert systems or the informations, and giving you the answers. These days, if you search for any product, some of the places, your website, you'll find that the chatbots are coming up. If you ask something, then it will give you the answer. If you ask something that what is the details of the product, it is giving you the link. Okay, so these chatbots are very much effective in the healthcare systems because it can do the job of a receptionist very well. Assisting the doctors with the patient's progress. Now the nurse may not be nurse's presence is needed if for that particular job to some extent. So the concepts, and what I'm taking is that you may argue, and how are you saying all these things? These are the concepts, and these are the concepts getting implemented in a very, very small level, small delta level. Now we have to do research so that these small delta which I'm talking about can be a big delta and can make a real impact in the manufacturing or the societal sectors. Even the Indian government, they set up a chatbot called MyGov Corona Help Desk. If you ask any question related to that, it will give you the answer suited to your questions. As I mentioned, that complete visibility of a shop floor is very, very important. Now, visibility of a complete shop floor means not only the machine, of every entities, including the human being, including the assets that you are getting using. So if you think of a manufacturing shop floor, of a product, then what happens is it has got the several stages. One is the planning stage, then designing, then the design is getting prototype, then you need to develop that. What are the difficulties? That is the design for manufacturing if you adopt the conventional manufacturing route, or to some extent the additive manufacturing route also. There also you have to think for the design for manufacturing. Then the actual manufacturing is getting done. Then after manufacturing, what is the fate of the product? Now, think of the washing machines or the air conditioners which are coming up these days. They are all network based. You just check carefully, you can also purchase that. So that means the manufacturer will get to know that what is the health of the washing machine, or what is the health of your the air conditioner fitted in your drawing room or the bedroom. So, and based on that information, the manufacturer will set an alarm automatically that you need to change your filter now. You need to change, replace the gas. So all these things it will come up very soon in your life. So that means it is not only the manufacturing of the product, it is the after manufacturing, post manufacturing, that is the customer satisfaction. So that's why I mentioned that the last one, which is the post manufacturing. All these concepts, when you integrate all these entities of the systems together, then you will get the complete thread in the digital mode, which is called the digital thread of the physical systems or the manufacturing software that we have. Presently, there is a huge disconnect among the stages. Planning doesn't take care much of what is happening, real-time happening of the post-manufacturing stage. Or the designing. If something is happening post-manufacturing, then the design team should have that information real-time. And then when they are designing, they should also think of the design for manufacturing. When the design for manufacturing is done, that means the manufacturing steps are told, and while doing that, executing that one, what are the difficulties in real-time facing? So that means everything has to be put in properly connected so that they become one digital thread. Here I have mentioned about only concerning to a product, manufacturing of the product, or that is called the digital thread of a product. But the digital thread, the philosophically means much beyond. It will also look into consideration of the assets being used, like your car parking area. How much the car parking area is getting used? How much is the vacancy in the car parking area? How much you have helped the globe in reducing the carbon footprint while printing that job? How much you have effectively utilizing a manpower, whether that manpower is over exercised or overutilized. So the concerned manpower has to be given a relief. So all these things are they're happening. Whether the nighttime performance is more than the daytime performance. I'll give you an example. I'll not take the name of that company and also not the product, because that's a little bit of confidential thing. One company is there, they are having two different manufacturing sectors. One is at the place X in our country, and another at the place Y. They are that is have a huge distance, so they are in a different climatic situation. Same design, same manufacturing steps. You think of the same company is the same, machines used to produce the product is the same, design fully automated, but the product at place X is different than the product at place Y, because the climatic situations are different. So all these informations are coming up. So what is the condition, environmental condition, when the product got used in the manufacturing sector, the place called X? And what was the environmental condition? People generally don't look much on the environmental condition of the product Y. There may be some impact of the environment on some of the products, not for all. So you have to think that what is your product and how much you need to put, how much you should concentrate on the environmental impact on the product. So taking that aspects also in the digital, the thread would be in one platform, so that the all informations universally happening, in different sectors or different manufacturing the places. Then it will give you the planned production with the ensuring the stability. As I mentioned, that the different type of product. You will have knowledge sharing. You get all information about what is happening, and you can also increase collaboration. So by these things, you can effectively use your manpower. You can also effectively collaborate with the other industry. Now, while getting the information that this robot is used only for the 10% of the work or the 20% of the work, and during the cycle time, and remaining cycle time can be. But the robot is inevitable. Use of the robots is inevitable, so that has to be used for the accuracy purpose. But it is not getting used for the entire cycle time of the product. So that means that robot can be simultaneously used for some other purpose. So all these informations can be, and then that could be a subsidiary product or the secondary product of the company. Same robot, same infrastructure. That means the industry is becoming more resilient and more agile in tackling or in serving the country in a greater way. So our help, the steps to help the MSMEs, because as I mentioned, I'm not bothered about the big industries much. I'm more concerned about the MSMEs because they are the workforce for the manufacturing sector. We have to give them the solutions for the retrofitting. Think of that, the MSMEs, they are more with the skilled workforce, less with the automation, and so they do not want to bypass the legacy machines or the old machine. We have to tell them that how can we retrofit. That means small, by taking the baby steps in their automation, how can you change, how can you improve their performance, how you improve performance of the product. It may happen that the complete renovation of that equipment is not needed for that product. May not be needed for that product. It may not be affordable by that concerned MSME. But if you can change a little bit, retrofit a little bit of that existing machine, bringing a required automation, then he can serve his job. So this concept of the retrofitting, and also these retrofitting concepts has to be taken in small steps, which is the baby steps has to be taken in the automation. And every solution, you think of this one, that every solution has to be the low cost. I've told you at the beginning that the solutions could be, let's say, the n number of solutions, but all n number of solutions may not be affordable. So everything you do, your focus should be, it is a low cost, and it ensures a certain quality. So then only the sustainable, you have mentioned that the sustainable and digital manufacturing. So the effort has to be, make it in a very low cost so that it can be sustained for a long period of time. It has to be completely digitalized so that it can tackle the coming days. Of course, this can be done by until and unless your workforce is trained. Now, whatever was the option in 2014 onwards, from the inception of the Industry 4.0, and then discussion took place followed by. So now that option has become a mandate. That means pre-COVID-19 era, people was thinking that the Industry 4.0 could be an option to explore intelligent and data-driven manufacturing. It is no more an option, it is a mandate. So the industry has to look forward in adopting the Industry 4.0 as quickly as possible to deal the dynamic supply and demand scenario. To have a flexible production line, as I mentioned, that the different products simultaneously by using the same infrastructure, and so that the product becomes smarter. That is the innovative products. So I'd like to quote the famous saying by the great scientist, the Einstein: "In the middle of difficulty lies opportunity." That means you have to be very, very positive in mind. Every sphere of your life, every sphere, every step you take, every class you attend, every seminar you attend, you always be open mind and be positive minded, so that you can learn something. It doesn't matter who is giving the lecture, who is giving the seminar, or whether it's a student or teacher or whoever it is. Every human being is different, and trying to pose or think the problem in a different way and trying to give the solution in a different way. So we have to be positive in mind so that we can find the opportunistic, the way even in the difficult days. Now, these are all the concepts that I have mentioned. I've told that this is inevitable, it has to be used. And so these are all philosophical statements and all. Now, how the Industry 4.0 solutions are given by the IIT Kharagpur, in a very short period of time. So there are some case studies I'd like to show. It is almost 1.5 hours. I'm speaking. There is no one to give me even a glass of water. So it is. I'm feeling thirsty. But anyway, I'll continue. As I've told that this is a very close, this is a topic very close to my heart. So what we have done is that we have done the real-time defect analysis and correction. You see that the monitoring is there. Defect analysis means it's the monitoring that is done in a real time, and correction is getting done in a real time by using image processing. That means we have engaged a camera, low-cost camera, captured the images, send that images in the cloud, and remotely we are operating that one. And whenever some the defects are coming up, how the machine itself by using its own AI and ML, how it is analyzing the process and overcome the the defect. So we have done some work. We have also filed a patent on this. That previous work was on the image processing, and this work is on the signal processing. Here we have engaged the sensor, that is the force sensor, and the force sensor, if something happens in the process, if your sensor is accurate and good enough, then the process, the phenomena, it will be reflected in the signals, the sensors data. So that means because sensors is the, can you please mute the microphone? Please mute the microphone. Yeah, so if something is happening in the process, please. If something happens in the process, then that can get very easily replicated in the sensors data. If a process going smoothly, you'll find that the signal, the signature of a particular sensor is something. It's a monotonic in nature. If something happens, then it will be having a different trend, just like our the signals taken used by various sensors by the doctors and all, from the the cardiogram, echograph and all these things. We get to know that ECG, get to know that what is the signal, whether something is something and some anomaly is there or not. Now if something is, but that is offline. But if something is happening, how we can take the corrective measures in a control, how we can control the process parameters so that the defect goes out. So this has been done in a single sensor. This is also been patented. I'll try to demonstrate that one. Why it is not showing it. So you see that initially I'll show you all the the videos at the end. Some linking probably is that. Anyway, don't worry, I'll show you at the end. So you see that initially there was a defect, and now the process changed its parameter, the online, and then ultimately the defect was not there. So that was done in a single, the sensor. Then we have used the multiple sensors like force, torque, and then power. And we have also engaged some other sensors to it. Now this force, torque, power got used in decision making to check the quality of the the product. So if some changes are taking place, obviously the data is sent to the cloud for decision, and then the feedback path is shown so that the process parameter can be changed to control that. If no anomaly is detected, so then it will follow the red path, so no parameters change, and otherwise it will be sent to the cloud and feedback path will be given. Now before sending it to the cloud, we are sending the data to the edge. That means the local computation. because we do not want to bog down the computational speed or the space of the cloud server. If something is needed, then only some changes is needed, then only we are sending the data. It's just like the CCTV. If there is no movement in the room, no need to store the data for a month-long period. If some movement is happening, that means something is going fishy, then only you need to store that data. Otherwise, if you want to store the entire data of the CCTV, then what will happen is that the entire space of the CCTV would be occupied. Would be occupied. By the time actual thing happens, movement happens, you will not have no space at all to store the data. So that's why we have whatever the the sensors data we are getting, whether force, torque, and power, we are initially sending it to the edge device, and if we analyze the process quality there itself, and we find out that if any change is to be taken place, then we are sending it to the deviation is there, we are sending it to the cloud. Now, how much will be the correction factor? That decision is being taken by the optimized ML algorithms, the placed at the cloud to send back the feedback systems to the system itself. So this is based on the multiple sensors. This has been done by using our doctoral scholar Devashish Mishra, who was the MTech student of your place under Dr. Kamul Pal, and presently he is doing PhD. So he is also working with large number of intern students working on the cloud computing, signal processing, image processing. So we have created a team working on this Industry 4.0 the area, and we are trying to come up the end-to-end solution. Like it is not, we are not going to give an hypothesis to an industry, or we are not publishing, the paper only. We are publishing paper, we are filing patent, we are coming up with the models so that the case study can be taken to taken by the industries with a little bit of tweaking. At the same time, we are also creating a digital twin, as I mentioned that when we are collecting the data, some sensors data we are taken for developing a digital twin to identify what is the health of that machine. Like oil temperature, speed, oil color, flow rate, oil level, all this information, we have developed a very primitive model of the digital twin of the health of the machine. So the first one is the real-time monitoring and control of the product to ensure the quality. And second thing is that what is the health of the machine at real time. So that is giving audio digital twin we have created, and that is giving a dashboard thing which will also show you. Now, while getting the success by using the single sensor, we have used the multiple sensors, and then you see here is the defective oil, and then constantly it is increasing its parameter, changing its parameter and coming up with the defective oil. So the single sensor versus multiple sensors. Single sensor versus multiple sensor. Single sensor of course take less time, but the time factor is very less in this particular example. So the multiple sensor taking almost the same time, but it is giving better benefit. You see the lower graph. The T stands for torque sensors, F stands for force sensor, P stands for power sensor, and T, F, and P are these are all three sensors data used simultaneously. More the sensors data, less is the number of predictions to achieve better and better the accuracy. Prediction error is also much less when you are using three sensors together. Why? Because we are able to judge the process from three different angles. Not only the force, in addition to the force, power, and then torque. There are some phenomena which are very well depicted in the force sensors data. There are some phenomena which are very nicely the shown, or the information can be analyzed out of the power data. So we need to do the sensors ranking, we need to do research on the sensors ranking to come up with which are the sensors, first of all, which are the sensors needed. where would be the sensor's location, so that you can get more and more information out of that. And after that, what are the sensors, you know, to be used? I mean, what should be the ranking? Whether should I judge this process by using the torque sensors or the power sensors? So in these fashions, you need to do a lot of research, and so we have done it, and we have found out the sensors ranking. We have quite a few publications on that. If you are interested, you can study those things and did the real-time thing. So you know, as I mentioned that we have created a digital twin out of the machine health. We have engaged different sensors, oil level sensors, you know, the RPM sensors, velocity sensors, or sensors, and turbidity. And finally, it will tell you what is the performance. Let me see whether it works. It is also not working. Anyway, I'll play that one. Try to play later on. This is one of the examples which we have done very recently for one industry. The industry is nearby, you know, very close to the Kharagpur. They were producing a product which are manually checked, and that also got getting checked on a batch wise. That means out of 100 jobs, they are checking just for, you know, the one sample. If something is wrong, they are discarding the entire batch. Now they just told us to come up with a, you know, the industry 4.0 solutions to that. Then immediately we engaged this is a discussion happened sometime in February 2019, just before the lockdown. Then we, in our team, we worked together. One of the interns of, you know, third year computer science interns of Jalpaiguri Government Engineering College, from my college, from my, you know, the graduated. So I told him, and you know, he came up with a very quick solution by using a low cost. It's a low cost, you know, the solution by using a low cost camera, which is a webcam. So he captured that images of the product, did the image processing, and did the real time solutions by using the image processing. It came up with 95% accuracy. Then we told that since the camera is a low cost you know, the webcam resolution is not good, that means information coming up out of the low cost webcam is not very strong, poor information. How can we increase the information, or how can we work better on the existing information? So we took the help of the artificial intelligence and implemented some of the concepts of the modules of the artificial intelligence with the same information, same images, and came up with the 99% accuracy. So these are the success. Real time it is happening, and after coming up with that one, you know, as usual, the company thinks that the academicians are very emotional about their research work, and maybe there is a long, you know, way to go. Definitely there are different steps, or there's a time, more time has to be spent. But so we requested for some other product, and we have done the same thing, and with the same accuracy we came up with this different product. And we created a GUI, graphical user interface for them without any cost, just trying to convince that industry effectiveness of the industry 4.0, so that they depend on our center of excellence in advanced manufacturing in future. So you know, we have created a GUI. Now the company owner, he can, you know, the sitting at his own residence, he can just visualize that. You can see that how many products are getting discarded, what are the, you know, when it is getting discarded, whether it is getting discarded by man 1 or the man X or the man Y. These are also very important, because when you do the manual checking, it is very much subjective. So these man-to-man, you know, these inspection also, you know, the changes. So you need to come up with a, you know, the low-cost solution which would be universal. So we did that one. For the second product also, we got the same success. And now because they are convinced now, so they would like to come to our place, but because of the COVID and our institute is in lockdown, so they cannot enter our campus at this moment. But we are happy. We are happy, at least we have done this, and then we are also thinking of some of the other products where we can implement the same thing. Now, we have created a center of excellence in advanced manufacturing technology, under which all these activities are getting done. It is a center of excellence in you know, it is an ecosystem, I would say, that where the large industries are there. We are taking efforts on for the MSMEs and all. So we got a huge grant from the Department of Heavy Industries, working with them for a long period, and how difficult it is to get a fund from the government. So and that too is a costly fund. So somehow we got the success, and then we formed a consortium of the industries, 6 industries. With the 6 industries' help, we started our journey. So industries also gave some fund. DHI, Department of Heavy Industries, gave a huge grant. With this support, we created the Center of Excellence. We are also in touch with the world best manufacturing research center, which is the Warwick Manufacturing Group in the UK. So we are constantly in touch with them, getting their guidance to take it forward. So this Center of Excellence vision and mission is that to inculcate these modern concepts which we have discussed just now, this all industry 4.0, so that we can add value in terms of its innovation, in terms of the manufacturing product or the processes and all. So in this ecosystem, we'd like to bring the large manufacturing sectors, small manufacturing sectors, academicians, researchers. Everybody should be on boards and discuss cohesively so that we can go forward. As I mentioned that we are having international expertise, WMG with us. We are also in the process of discussion with the University of Manchester in the UK. And not only we are doing research, we are also giving training to our industry people and also to the startup. While executing the research, whatever the innovations we are coming up, we are filing patent out of that. So these are the vision and the mission statements, not only residing in the form of statements, we are actively into it. So the ecosystem of the center is that we are having 4, the research thematic areas, the material research, then automation, additive manufacturing, and then industry 4.0. And here the 6 industries, 4 are Tata Group member, Tata Motors, Tata Sons, Tata Consultancy, and Tata Steel. And we do have 2 public sector industries, HEC Ranchi and BHEL, Bharat Heavy Electricals Limited. We do have now recently 1 startup has joined, Hemraj Infocom. So the 7 industries are there. So the 6 industries initially they gave their own, the industrial problems. Some of them it was very much futuristic in nature. In some cases it was eminently, the requirement. So our faculty colleagues at the Center of Excellence, faculty colleagues are from the different, the disciplines like computer science, electronics, then mechanical, manufacturing, metallurgy, industrial systems engineering, mining. So we are all working together. Around 18, 19 faculty members are there. We are all working together cohesively with the industry partners. It is unlike the consultancy project. Consultancy project, industry gives the topic to the faculty members, and then faculty member independently solves it and give it back to the industry. It's not like that. Here, both the entities are working together. So that means we are learning on a daily basis from the concerned industries. I am engaged in one of the projects with the Tata Consultancy Services under the Center of Excellence. And every now and then we are having discussion. So I am learning what is the need, what is the thrust for the industry, how they would like to see. Industry is also learning how the academician is working. So what should be the input from their end? What should be the takeaway from the academician? So we are jointly filing patents, and then we are publishing papers as well. And now one of our innovations like the multiple sensors, the real-time control, that they are thinking effectively that with a little bit of tweaking, how that can be commercialized. So they are actively considering that one as well. We are, trying to bring these startups and the MSMEs on board so that they are educated on the digital twins, and they can make themselves, up to date, as far as the innovation of the technology is concerned. At the same time, they will be also getting to know that what the big industries are thinking for the future, how they can be very easily align themselves with the need of this, the big industries. So we have created an innovation lab costing 24.87 crore, where large number of equipments are there, very sophisticated equipments are there to help anybody who can come forward, academicians, researchers, startups, and then MSMEs. Of course, nothing is free in this world. Apart from your the mother's, your parents' blessing. If something is to be used, then obviously you have to spend something. But the expenditure is not very costly. At least you will get the access of all these facilities, and you can fulfill your dream. So different infrastructures are getting the developed. The hybrid manufacturing facility it can print both different types of the metallic, the large jobs close to 800 mm. We are in the process of installation there. Then we are having a scanner which will scan any spare part, give you the coordinates, so that any defective, any product, spare products, you do not have the design, but you'd like to reproduce that one, you can very easily do it. And then we have a very sophisticated, UTM machine costing 2 crore. The additive manufacturing machine costs 9 crores, close to 9 crores. UTM is close to 2 crores, where during deformation you can also make video and see that how deformation is taking place. If you have manufactured any product, fabricated any product, you can check it, you can scan it by CT scan system, and it's a large scanning system. It will be first time in our country, where close to 1 meter job can be scanned and find out what are the defects. So this is about to be dispatched, costing close to 6 crore. There are other facilities like the 5-axis CNC machine, and this is a very interesting machine, first time in our country. There is a robotic vibration testing. So if you want to see the endurance or the fatigue life of any component that you are designing, then you have to subject that component to that particular loading scenario for a long time, and you have to check the level of vibration. And the level of vibration, mostly it is getting done by the accelerometer. In that case, there is a physical contact between the sensor and the physical object is needed. Whereas if you use the laser scanner, and then you can scan, if you can use the laser scanner, on top of that, if it is of a scanning facility, then it will scan the entire surface for a long period of time, and it will give you the mode shapes, and then also the level of the deflection of different components when the equipment itself or the product itself is subject to different loading situations. This is a robotic friction stir welding facility. We are procuring facility which are of industrial scale. Unlike the other institutes and the labs, we are doing it intentionally because we'd like to take convert the activities of the Center of Excellence to a catapult center. That means we do not want to reside only in the academic research. We want to take this concept and upscale it and to come forward as a product. Now, for a product, two things are very much the required. One thing is this the upscaling, and another thing is that the subjected to the same environmental the effect. Now, upscaling, while if you are having a prototype, from the prototype to the upscaling, that means small job to the small size product to the larger size product, there are lots of difficulty. So instead of going into fabricating a small product, we'd like to do something which is the industry accepted size, so that we can produce that one. That's why all facilities, cities starting checking from coming up with the hybrid manufacturing, the facility, additive manufacturing facility, or the 5-axis CNC facility. These are all industrial scales dimension. I'll also show the video at the end. This is the thing which I'm talking about. We are in the stage of creating this facility. The infrastructure has come up already. Very soon we will install that. We have procured one robot. Robot is mounted on a linear track, and then robot would be end effector of the robot will be having 3 laser scanner. So it will scan the vibrating object and and give you the mode steps and all these things. We are having other the facilities. If you are having a vibration, you will be curious to know where from the sound is coming, the source of vibration and all these things. We have procured acoustic holography and some of the facilities and all. We have placed a purchase order to these complete robotic welding solutions, like the different types of the welding robotic welding facility would be fully integrated with the robots. The sensors, and then you'll get to know about the process and its health in one platform, like the MIG welding, spot welding, TIG welding, and then laser welding, 6 kilowatt laser welding, and then cladding facility. We are giving training programs to the industry people, the students, ITI student, diploma student, degree college students and all. We are giving training twice on the CNC. We have organized a workshop on, going to workshop on Industry 4.0 and also we are in manufacturing. But these short-term courses and all these things got stuck up because of this COVID. But the CNC training program got done twice already. And then these are some of the glimpses of the training program that thing. You see the participants from the undergraduate, research scholar, faculty, even the industry professional. So this is the first weekend training program. We had 3 weekend training programs. Then these are some of the glimpses of the 3 weekend program. The students are there. We are giving, showing them how to do this thing. Then we conducted a workshop on metallography it was completely, the lectures were delivered by the eminent, the metallographer George Vandervoort, with the support from the stewards and the Center of Excellence in Advanced Manufacturing Technology. You see, these are the participants, large number of participants were there. Even the IIT faculty members were also present. So that's a very good thing. Then we came up with a short-term course on the Composite 4.0. That means how Industry 4.0 can be implemented in composite manufacturing. This is our boardroom of the Center of Excellence. And here the speakers were mostly from the industry. Airbus, Tata Autocom, the composite world. And then outside universities, along with the experts from IIT faculty. And in this particular seminar, the lecture was given by our Deputy Director, Professor Siman Kumar Bhattacharya. As I've told that our COE's aim is to come up with a catapult center, like how the research, fundamental research can be upscaled for the implementation or takeaway by the industries. So we'd like to reside in this zone of 4, 5, 6, which is the value of depth generally. 7, 8, 8, 9 is the industry's need, and 1, 2, 3 is the academic. So there is a disconnect, but our Center of Excellence is already residing in almost 4 and 5. I would not say completely 5, it's a 4 and 5, because our infrastructure is of the industrial scale. So upscalability would be very much easier for us to take it forward or put it on the plate of the industry's food. This is our 40,000 square feet industrial shed we have constructed in a record amount of time, including the COVID. It has come up in 1 year, 2 months period, with a cost of close to 9 crore. And this was a recent visit by our director and deputy director and register, and then this is myself, and then our Dean Street and one of the faculty members who is expert in the additive manufacturing. Now, the vision of the COE, I would say that we, as I mentioned, the vision and the mission statement of the COE, we have started working on it. But in my understanding, I'm a very small person. My understanding is that it would be fully successful if and only if agar tum saath ho. That means I need the presence of everybody, the industry and the academia. It is not a one man's job, or it is not a job of one particular institutes like IIT Kharagpur. Since you see that the something, if we need to produce as a product, then we need to listen to what is the industry's need. What's going on in the market. So we need to understand the market strategy. Lots of products, lots of innovations are coming up, but not all the products or all the innovations are getting the limelight. So we need to understand that what are the difficulties, what is the need of the consumer, and what sorts of innovation or the flexibility we need to bring. If I think that the Professor Surjya knows everything or the IIT Kharagpur is capable fully, then the person who thinks or possesses this sort of idea is a wrong person. So I need that everybody's presence is needed. So that's why agar tum saath ho, then only we'll get the success of this Center of Excellence. It is just 12 o'clock in my 12, just 1 minute past 12 o'clock. I was given 2 hours time by Dr. Kamal Pal. So Kamal, I have finished within your time frame. And if you have any questions, I'll be more than happy to answer.
Okay, thank you, sir. We have a couple of questions from Rasmi Ranjan Mahapatra. One question is in Industry 4.0 implementation regarding the capex requirement.
Yes, I told at the beginning, if you have listened carefully, that not, you know, it would be very wrong if we replicate the entire thing or if we copy entire thing. And that's why we are struggling. You know, whenever something comes up in the Western world, we are copying it. We are exactly copying it. That's a wrong concept. We need to understand that what is the benefit of that. You copy that portion which would be suited to your purpose. You copy that portion which would be suited to your purpose. So you know, if the level of exercise a foreigner is doing and or you are doing, if I do perform the same level of exercise, thinking of my own health structure, then that would be the wrong thing. So you need to understand that what is the infrastructure that you have, how much infrastructure it is needed, so that you can see the benefits and you can also see the profit. If you try to implement each and everything at the very first goal, leaving aside the legacy of, you know, the machines or the age-old machines, then you may not, and the cost of, and then product cost is very less. So unless you can produce in a large amount of time, so all these factors are there. So as I mentioned, the Industry 4.0 is an umbrella. Under this umbrella, lots of things are there. You need to understand your need and think of how best it can be utilized. So your capex has to be very, very well studied, and then how much change you can bring in the capex. Okay, whether the complete change is needed or not, that has to be looked into. As I mentioned, that you see the MSME, their skilled manpower. Now, that particular generation, if I think of my generation, let's say I'm an MSME, I'm older, and I'm skilled, I'm happy with my the infrastructure. Now, Industry 4.0 has got benefits. If I could have used that, that would have been nice. Now, as I'm becoming, you know, the aged, my next generation may not be that much of capable in doing the same job. So then the thing is that, so I need to gradually implement these concepts so that irrespective of the skill of a particular over a generation, the people can do the job effectively. Yeah, next question, please. Meanwhile, I try to. Next question.
Industry 4.0, we are dependent on AI and web.
In this pandemic,
So in this
COVID-19 situation, if
internet or web will failure, then how an industry will
run?
I didn't get your point. Can you, voice is not clear. Can you speak? Microphone, थोड़ा सा adjust कर लो. Yes.
Sir, actually in this Industry 4.0 era, it's depend on AI, internet and web and cloud. But like in COVID-19 pandemic situation, if internet or web will failure, then how an industry will run?
You see that if you know if a skilled manpower is there, okay, for producing something, and that manpower is not available, then you will not be able to do that job. Never ever think of a negative thing in life. You have to be like how best you can utilize that. Today, you know, can you thought of the concept of the virtual VC just 3 months back, 4 months back? Have you thought of? And have you thought of the internet connection at that time? And now what is your takeaway? Have you thought of the WhatsApp or the sending the SMS or the beautiful picture of yours to a dear one these days, which you are doing? I'm pretty sure you are doing that. So have you thought of these things previously? Or was it possible previously? So it was not. So that means when we think the potential, so the usage or the infrastructure capacity is also increasing. Today the car is coming with lots of the facility. So that means the research is also going on. How can we increase or enhance the network speed? Initially we had the 2G, 3G. Now 4G is there. 5G has also come up. 5G has also come up. Now in 2G era, people could not think of. But because of this network, the access of this data and all this in industry in 4.0 is possible. That means we need to research, we need to work on that, how this could be taken forward. Next question, please. Yeah, I am trying to also show the videos, some of the videos.
Sir, one more, sir.
Yes,
one participant has a query that what is the current and future scope of research pertaining to this IoT and 3D printing technology combination?
You see that in IoT and 3D printing, additive manufacturing or 3D, the printing is a new manufacturing paradigm, which I have told. So that in that process, that is also a process. Now, if you'd like to see that, what is the performance of the product, how the quality, what is the process quality, how is the health of the 3D printing machine that you are using. So there, this in IoT or the industry 4.0 is irrespective of the type of machine or the process. It could be additive, the manufacturing. It could be a robotic facility. It could be a conventional machine as well. So the example which you have given, the implementation of the IoT or the industry 4.0, that is on the CNC machine, friction stir welding machine. Now we are working on the robotic machine. Now when the additive manufacturing will be fully working, we'll be working on the industry, working on the additive manufacturing facility. You try to think in that way, like the sensor, your same stethoscope can be used to you or the, let's say the patient Y or the patient Z. So the methodology is almost the same.
Okay, sir. We are done with the queries.
Okay, very good. So I'll try to see that whether I can show you some of the what is that, the videos. Let me see whether it's possible. Can you see the screen? Can you see the screen?
No, sir, no.
No, sir, it is not visible now.
Not coming, now?
Yes, sir, it is
coming.
No, sir, it is not coming.
Anyway, so the video, some problem is there with the video. Every time I face this difficulty. Anyway, so any other question?
One participant has a query that sir, how can we reduce the solid wastages in manufacturing processes?
You see that when you think of the wastage, then first thing you have to think for that, what is its utilization? What is its utilization? So you have to think for that first. Like how much it is getting the utilized, whether it is scope of the reduction or not the possible. That means complete visibility of the system itself is the required. Then only you can implement the industry 4.0, the solutions in the solid waste management. Okay, so for any management, if you would like to manage something, you would be able to do if and only if you know that process, you know that system. Then only you'll be able to. If I am the principal of a system or the director or the vice chancellor of an university or something like this, Until and unless I know that what is happening at each and every corner, then I cannot come up with an very sustainable the solution. And I will depend on the digital methods to come up with a sustainable solution to handle that system. चाहे वो industry हो, चाहे मेरा home हो, चाहे वो मेरा let's say the academic workplace. So that means the management waste, even the solid waste management and all, you need to understand that what is its utilization, how much is need, how much, whether there is any possibility to reduce that thing or not, utilizations, and if so, then what will be the revenues for the utilization? Okay, so can it be anything? Let's say the solid waste can be converted to something else. So the new technology, you have to think for the new technologies. Utilization, new technologies, all these things will give you automatically path that how to go ahead.
Okay, sir. No more queries, so we can go for the conclusion now.
Just a minute. One person is telling is that if I can share the entire screen, then hopefully the thing will come up. So let me see. Just a coming up.
Yes, sir. It is coming now.
So now it is the robotic facility. It is not the facility of ours, but we have procured the same facility that installing it. There you see the two robots are there. The laser scanner, which will scan the entire surface of the vibrating object. There is the chassis. So we have procured, from Polytech one robot, one track, and then I'll show you the defect. This is the real time. Can you see this slide? Can you see the slide?
Yes, sir. It is visible, properly visible.
Yeah. So it is the real time process control. We have say recording this one sensor's data. So initially some defects are coming up in the welding, the process, the sensor welding process, and then we control the defect. So we were capturing the data, and the students sitting at IIT Mesa in Ranchi. So sitting there, what are the defects are there, he can monitor and he can also control. You see that it is changing its RPM, and finally the picture which you have shown that the defective product and final thing. And then this is audio, the
digital twin application.
This is the audio digital twin.
Processing started. FSW tool health monitoring started. The values of wavelet coefficients of force signal is 380.
So it is constantly telling
The
about
values of
what is
wavelet
the force
coefficients
signal
of power
data,
signal is
how much is the
1023.
deviation.
Tool health currently okay. This is predicted with 82% confidence. FSW feed motor health monitoring started. Under 100 millimeters per minute speed,
at different
performance
speeds, how much
degradation
is
by
the
1%.
difference? So that
Under
can also be
200
taken into
millimeters per
consideration
minute
for
speed,
the controlling.
performance degradation by 1.5%. Under 300 millimeters per minute speed, performance degradation by 2.67%. If you would like to restrict speed always under 200 millimeters per minute, press 1, else press 0. User input.
So
User chose not to restrict speed under 200 millimeters per minute.
So depending on the health of the machine, the process parameter, you see that something you have the optimized parameter, but that model says, but the machine health is not capable in taking that that parameter. And then this is our robotic facility, which has been installed in our fish sensor welding laboratory. Hope you are able to see it. This is also highly sensor integrated, but we will start this work in the industry 4.0 solutions in this particular case. We have done it successfully for our CNC machine, but we are yet to start on the robotic facility. So these are the thing I wanted to show. So thank Devashish that you have mentioned that how to. Sometimes we need to listen to our students as well. They are smarter. So at least in my case they are smarter than me. So I learned this thing a lot from them. Is there any other questions?
Sir, any remote lab set up in IIT Kharagpur?
Yes, we are.
Students?
Yes, we do have the virtual labs, already developed by Prof C.S. Kumar in Mechanical Engineering Department. So for the, under this, the initiative from the ministry.
Government of India.
Yeah, Government of India. So it got done. So there are quite a few labs which can be done virtually. But since the Center of Excellence is an interdisciplinary research center, it is not under the Mechanical Engineering Department. So here we have just started. So 2018 we just got the fund, but within one year period we could construct with procurement and all these things happen. But we are also planning coming up with the virtual labs, especially on this thing. So CNC and then robotic facility, which we'll do very soon. We have already started working on CNC.
Sir, robotics is the future. All the repetitive job by industry will be replaced by robotics. So this is the need of the also future robotics.
No, robotics is the future. It's not a true thing. Robotics, there is a potential for of robotics to be used in the future. Lots of other things are also there. Partly you are true that this could be used grossly in the coming days, and so the major concern is that someone has written the AI is the future.
All are required. AI, machine learning, all are. Too many things are there. That is digital twinning, physical world to digital. That is the need.
Nothing is the ultimate, but everything has got the potential. Somewhere you will find the more potential, somewhere you will find the less potential. Okay, but the automation has to be taken forward. That is the thing, taken forward along with the manual. So we have to reduce the manpower thing as much as possible. So people are debating that if we include the industry 4.0 robot, more robots are used. What would be the fate of the human manpower, especially in the country like ours in India? and but there are counter logic is there. Definitely there will be the there will be the reduction of the jobs. The nature of the jobs will also get changed, but there will not be scarcity. Only thing is that the workforce has to be gradually trained with these digital tools, with the various tools of the automation, so that they can do a different job. So that's the thing. So, and number of jobs, in fact, it will increase, but the nature of job will, what they previously used to do, that will be that will be the decrease. So for every one robot, there is a statistics given by the University of Oxford. I just read in the net that for every robot there will be a maintenance of throughout its life period, the 3 manpower are required. So that means manpower requirement would be more. The number of jobs would be more, but it will be at a different level. So you need to have the knowledge of the STEM, science, technology, engineering, and mathematics. Then only unless you can raise yourselves, you can lift yourselves to a different level, then you will having different. Previous in our time, hardly I'm 50-year-old now, but my gray hair says that I'm quite Buddha. It's not like that. So now in our time, hardly people used to go for these MTechs and PhD. When I opted to IIT Kharagpur, people thought that cleaning so
Sir, old is gold.
No, old is gold, that's a different thing. Old is gold, and how much purity of gold is there, that's a different logic. So
All are following our
but I'm
ancient
not,
culture. All people
no,
following our
I'm
ancient
not,
culture.
No, but I'm not debating on because it's a public forum. I'm not debating on that. What I'm telling is this: the outlook has that got changed. Even the knowledge which was there in the graduation level, which was people used to think that this is sufficient for the job to be executed. Now they are thinking, the same organization is thinking that I need to have a postgraduate student. Because the nature of it's not like that the students are knowing less. They may be doing more, but the nature of the job has got changed, which demands more knowledge. So that's why now the people are studying for concentrating on the postgraduate thing and all. Similarly, the people who used to job previously, the way it was getting done, for that, whatever the skill was available, that was sufficient. Now, because of this digital era, people are thinking in a different way. The knowledge of STEM, science, technology, engineering, and mathematics, STEM, is very, very required. Thank you so much. I think there are some questions coming up, but I find those are not very relevant. And if you'd like to have more discussion, you can always ask me personally. But it is called close to 2.5 hours. So I'm feeling thirsty. I have not taken a glass of water. I think this is.
Sir. Sir, thank you very much on behalf of Dr. Kamal Pal, our HOD sir, who has left for a meeting with the Vice Chancellor. On behalf of Department of Production Engineering, all the faculty members, the current participants, I would like to express our sincere gratitude to you, sir, for accepting our invitation and putting forward your experience and expertise in this domain of this seminar. We are very much fortunate to have you, and we look forward to see you at our own campus in future, sir. It will be a blessing for us. So with this, I'd like to thank you and also the participants for their patient hearing. As Sarah has told, already means it is 2.5 hours. So long. This is the longest session that we had till now. So thank you very much, sir. Thank you, participants.
Thank you so much. Thank you so much. I hope you could see all the slides and there was no problem with the audio and also the video.
So the feedbacks from the participants are there in the chat box. They are telling it is an excellent and informative presentation.
Thank you.
And the PPTs were so nice.
Thank you, sir.
Thank you, sir. Thank you very much.